Hi everyone, I'm Iveta. Want to set up a constant, uninterrupted flow of fresh data without even bothering to start it every now and then? The easiest way to do so is to run a script in the background. In other words, to run it as a service. No matter what operating system you're using, Linux or Windows, keep watching this video to find out how to run a Python script as a service. In this video, we will be scraping a list of book URLs from books.toscrape.com. Start by writing some code that puts 3 URLs into the URLs variable. Then, let's write an infinite loop that goes through the URLs and fetches the content using the requests module. So, we've fetched the content and now comes the parsing. Use the beautiful soup library to parse the content and extract the book name from the main product heading tag. We're also gonna grab the rest of the product info by going through the rows of the table. Now that we have the data, it's time to save it. Create a data folder object that references the data folder that doesn't exist yet. Use that object to make sure that folder is always created if it doesn't exist. Since we're gonna be using the book name as the JSON file, make sure to normalize it and use it as our final path for the JSON file. Once we have it, open that new JSON file and dump the JSON data that we've gathered. Let's run the script. As you can see, it goes through the same data over and over again, refreshing it endlessly. To stop it, press the Ctrl-C combination on your keyboard. As you can see, it immediately fails. That is not a very graceful exit. Let's fix that next. To exit, we have to define a class that handles the system signals. We will call ours Signal Handler. Define the class property shutdown requested that informs us whether the system has requested to shut down our script. To support it, let's define the setter of sorts. Request shutdown will mark the variable as true. Next, we define a method canRun that determines whether the flag is false, effectively telling us whether we can continue executing the script. The most important part, though, is to use the signal module to register the request shutdown with the system. Now that the system knows to invoke the request shutdown method in case of a shutdown signal from the user. Now create the signal handler instance and use the canRun method, the loop condition instead of true. Let's run the script using the terminal and press Ctrl-C again. As you can see, the script now handles the exit gracefully. We're now gonna use one of the most popular Linux distributions, Linux Mint Cinnamon, to run the script in the background. Open System Settings and find Startup Applications. Fill in the name of the script and the full path to the script file. Add an optional comment and you're done. The script will now run in the background. However, this approach doesn't provide more control over the script. For example, what happens when you need to restart it? This is where systemd comes in. Systemd is a service manager that allows you to manage user processes using easy-to-read configuration files. To use systemd, we have to create a configuration file. Switch to the root user so that you can access the systemd configuration directory. Once you change the directory, create a text file. We are gonna be using Vim in this tutorial, but feel free to use any editor you like. The name of the file doesn't matter, what matters is the content. Here's the basic rundown of the parameters used in the configuration file. After, ensures you only start your Python script once the network is up. Restart sec, sleep time before restarting the service. Restart describes what to do if a service exits, is killed, or a timeout is reached. Working directory, current working directory of the script. Exec start, the command to execute. Time to tell systemd about the newly created daemon. Run the daemon reload command to let the system know new files are available. Then start the service. Once the service is started, you can also check its status. Here is a pro tip. Use journal.stl-s today-u book-scraper.service to monitor your logs in real time. Congrats, you can now control your service via systemd. Running a Python script as a Windows service is not as straightforward as one might expect. Let's start with the script changes. Since we are gonna be using the Windows methods to handle the service state, get rid of the signal handler class and clean up the code. Let's also use the full path to the data directory in the Python script. Create a class that extends the service framework. This will allow us to tell Windows about what our service does. The service name, display name, and description will all be visible in the Windows service utility, service.msc, once your service is up and running. Write an init method for setting the service framework up. Define a getAcceptedControls method to tell Windows we want to accept and handle pre-shutdown events. The most important method is svc-do-run, which does all the work. Let's put all the code we have there. Also, add an svc-stop method for handling the case when shutdown signal is sent to the script. If the script receives a single argument, we need to assume that Windows Service Manager is attempting to start it and execute the initialization code. If 0 arguments are passed, print some helpful information by using win32serviceutil.handle command line. To run the service, we have to install the pywin module that will let us communicate with the Windows API and run the post-install script. Also, install the pyinstaller module, which allows us to package Python scripts into neat, self-contained executables. Let's use pyinstaller to turn our interpreted script into an exe file. The hidden import Win32 time zone option is critical as the Win32 time zone module is not explicitly important but is still needed to run the script. To install the service, execute the script with an install argument. If you run it without administrator privileges, the command will fail. Run the terminal as administrator and install the service. Once it is successfully installed, you have to start it. The script is stopped by default. You can now open the Windows Services utility and see the new service you created. As evident, you can use Win32serviceutil to develop a Windows service. But the process is definitely not that simple. Well, this is where the NSSM comes into play. Let's simplify the script by only keeping the code that performs web scraping once more. Delete all the things that are specific to Windows API and keep only the code that is universal. Using the same process we did before, bundle the script into an executable. Now visit the official NSSM website and download the latest release. Unpack the contents to a directory. We are using the apps directory. Lastly, add the NSSM binary location to the path variable so that we can invoke it in any folder without specifying the full path to it. Now that everything is in place, create a service using the NSSM binary by passing the install argument, the service name, and the location of the bundled Python script binary we created using pyinstaller. Once the service is installed, you can start it. It's just that easy. Here's a pro tip. If the service doesn't start as expected, you can set the standard error output file and see why the service fails. You can also manually run the bundled Python executable to see if it runs as expected. I hope you found this video helpful and learned how to run Python as a service. If you want to see more content like this, hit the like button and share it on social media. If you have any questions, feel free to contact us at hello@oxylabs.io. Thank you and see you next time.